Hello, my name is Santiago Martinez, and we'll be going over Exam 3, Problem 10, the last problem on Exam 3. And it is a word problem, multi-step, three-step problem, and I'll walk you through all three steps. Excuse me. The first part is just giving us information to know. I will just be writing it here just to let you know what the information is and everything that's given. So I'll read it out to you. CU Boulder had a student population of 38,000. So student population of 38,000. There is an outbreak of the flu B. If the spread of the disease is projected by the formula, F of T is equal to 38,000 over 1 plus 999 E raised to 0.011 T, where T is minutes. This is the information that's given. Again, CU Boulder has a student population of 38,000. There's an outbreak of flu B. If the spread of the disease is projected by the formula, F of T is equal to 38,000 over 1 plus 999 E raised to the power of negative 0.0011 times T. So going off this information, we can start to analyze what A is asking. So A is how many flu B cases are there when the academic began. So how many at the start. So the way that we do this is initial, right? This is the starting of everything. So we can write this as F of 0. And we plug in 0 for T. Because this is the very first start. So we will have 38,000 over 1 plus 999 E raised to the negative 0.0011 times 0. Then we have to simplify this. So F of 0 is equal to 38,000 over 1 plus 999. And as you can see, we're just going to have E to the 0. And we know that anything raised to the 0 is going to be 1. So then we can rewrite this as 38,000 over 1 plus 999. We know that E is 1, and that being multiplied by 999 is just going to be 999. So then we can simplify further as F of 0 is equal to 38,000 over 1,000. We can knock off 3 zeros, giving us 38 over 1, giving us 38 people had the sickness when it started. Nice. So now we'll move on to the second part. We'll move this all a little up to maximize the amount of room that we have. Right about there should be good. And I'll change colors as well, not to be confused. I'll put A right there. Now let's do B. We'll do B in blue. And B is asking how long does it take for 1,500 people to catch the flu. So now in this situation, we are given our Y value, or the amount of people. So 1,500 people halves the flu, and we'll set this equal to our equation and solve for t, because we're looking for how long in time. So 8. So we have 38,000 over 1 plus 999 e raised to 0.0011 t. And let's break this down. So how would we solve this? So right away, we're going to multiply the bottom term. So we should have 1,500 times 1 plus 999e. It's a lot to write, I know. Just stick with me. Is equal to 3,800. Beautiful. Now we can divide by 1,500. Both sides. And we should get 1 plus 999 raised to 0.0011 t is going to be equal to 3,800 over 1,500. We'll simplify that as well. We'll have to subtract 1 on the side as well, so we'll do that at the same time. So we have 900 and 900. E raised to 0.0011 t is going to be equal to 38 over 15 minus 1. And then we can write it as we could divide by 999 to get e by itself. So we should get e raised to 0.0011 t, and that should equal 38 over 15 minus 1 all over 999. And then we take the natural log of this value. To get rid of e. And then we will get 0.001. This value we'll have to put in the calculator, that way you can actually tell what it is. So we'll get around 6.4793, and then we will obviously divide by this, and we will get t is equal to around 5,890.28, and we'll put that in minutes. So don't say so it will. We can word it in a better way. We'll say it will take 5,890 minutes for that flu to reach people. Awesome. Make sure we're writing statements after every single one, and we're going to take this to the next page, the final part of this problem, which will be graphing it and also determining the limits of this problem. So it asks what is the maximum number of population possible to catch the flu. So this is a limit, so we'll do that right now. So we'll write it as, let's change the color. We'll write it as limit of 38 over 1 plus 999e to the 0.011 times t, and we'll write that as t is approaching infinity. So we'll plug in infinity in this situation. So we'll do 3 38,000 over 1 plus 999e raised to 0.0011 infinity. And then in return, we'll push that, and we should get negative infinity in our exponent. I know a lot of writing, but stick with me here. So we have 1 plus 999e raised to negative infinity. And then again, we'll bring it down here. Now what do we do at this point? So e raised to a negative value. We really don't like that, so we'll flop it here. So we'll have 38,000 over 1 plus 999 over 1 over e to positive infinity. Now, we can write this as 38 of 1 plus 999 to the 0, which will give us 38,000 over 1, which is also equal to 38,000 flat. And that's going to be people is the maximum that we'll ever see with this virus. And so that will be the HA. So when graphing this, we have a fun little graph to do. We'll actually make this as big as possible to be easier. To see. So we'll draw a normal graph. And then coming right here at the very top, we'll put this back down to this and change this. We'll have an asymptote, leave some room to write. Horizontal asymptote at 3,800, and we'll mark that. Our starting point will be here, and this is 38 people. And then what's going to be our next point? Well, we can actually go up here, and we know 1,500 is a value that we have for y, so we can jot that down right here, right about there. You want to kind of make it as accurate as possible. It's hard with these big numbers. So we have 15, there we go, 15,000 right there is our starting value, which we get from our second part of the equation. And then we actually get for our x value, which or t value in this situation, 5,890. So we can put that right about here, 5,890 people. And our graph starts right here, and we'll curve up. Excuse me, we'll curve up to this second point, and then you'll see it kind of start to plateau out ever growing towards there. And this will be t, and that's how you represent that. Again, we get these 2 points. This point is our starting initial point, and we start to curve up, and this point is that we get from right here, whatever time frame that gives us. Remember, it said 15,000 people have it at this point, and it takes around 590 minutes to get that. And then we figure out our HA by using our limits, and that's how you do that problem. 3-step problem. Thank you so much. Hope you have a great rest of your day.